Hello, and welcome to Refactoring PaleoRose. My name is Tom, and this is PaleoRose. PaleoRose is an application I started writing in the year 2006. It is designed to help display statistical directional data, such as collecting data about wind direction or river flow direction. You can plot it on this graph and have a better understanding of the data. Let's do a quick demo of PaleoRose. On the right, you see this circular diagram, which is used to highlight the directional data. On the left, we have layers, and on the bottom, we have tables. The idea is that you could have multiple data sources in different tables, and you can have different layers with different data. But let's keep this simple real quickly and load up our first test set. As you can see in the preview, this test set consists of an array of numbers from 0 to 360, highlighting directional data. So when we load the data, it could be a number of different file formats, so we have a little bit of flexibility in terms of file formats, and we can determine whether or not there's a column of data or a column title or not, and we can bring it in. So now we have a table. Now it's possible we may want a subset of this table, but for now we just want to use the whole table. So let's load it in. We'll give it a name, create the table or the layer, and there we go. So what this diagram is now showing us is that the entirety of the data set suggests that there's flow in the direction of the northeast. It's a pretty straightforward app in many ways, but there's a lot of flexibility in terms of appearance. You can change what colors are represented by the data, what the spacing of the lines are, how each wedge, as you can see in here, is drawn, and how big those wedges are, and those sorts of things. But we can get into those details later. There's a lot of complexity inside this app we're going to have to fix first before we can work with this user interface. While this app seems to be working, it does have a problem. The code is mostly old and, quite frankly, poorly written and needs freshening up. In fact, there have been no significant changes to the code base for at least 7 years. And a lot has changed in those last 7 years. So it's time to take a journey to refactor this old app into something cleaner and more modern. Obviously, I can't share this journey in one video, so I created Refactoring PaleoRose to document this work, and hopefully we can all learn something in the process. If you want to follow along and better understand the code or try refactoring yourself, I made the code open source with the MIT license. Feel free to fork the project for your own experimentation. Before we begin, let's start with a couple of ground rules. We are not technically rewriting this app, although by the end of this process, the code will likely be 100% new. The goal is to keep this app fully functional all through the process. If we rewrote the app from scratch, it may take 6 months or a year before a new version could be released. But what we want to do is make changes and make new versions available all along the way. So it's not technically a full rewrite. What we're doing is refactoring the app. Second, all new code files must be in Swift. Now, there's no reason why we have to make that rule. I just prefer Swift over Objective-C these days. And as a consequence, we have to do some of the right things along with it. We want to use other tools to help keep our code as clean as possible. For example, SwiftLint and or SwiftFormat. If we can keep our code clean and easy to read, the better off we'll be in the long run. Third, I'll try to keep a list of the tools and software and any kind of links to reference materials inside the descriptions for each video. It's kind of important to be able to read these things on your own, and feel free to disagree with me with some of these changes. You'll be free to comment for each video. Fourth, we should be kind to ourselves in terms of our past, present, and future selves. As I mentioned, for example, that there's a lot of things I did wrong in this code base. But the app actually works. You can see that I can plot these data. I don't like how it's written today, but you know what? I was doing the best I could at the time. And that's a fair assumption that we should all give ourselves about our past work. A lot of times we don't like it, but we were doing the best we could at the time. And we want to be kind to our future selves by making our code as clean, legible, and where needed, documented as best as possible. You may very well write an app that you come back to 20 years later and want to freshen it up. And if you kept it clean and easy to understand, it'll be much easier to deal with. So we need to be kind to our future selves. And when you think about it, any team you might work on is a combination of your past and future selves. Your teammates do some work, you work on that, you have to assume they were doing the best they can. Don't beat them up for it. And people coming after you to work on your code, you want your code to be as clean and understandable as possible, so you don't make them have to work harder than they need to. So with those ground rules in mind, let's take a look and see where the app currently stands. Whenever I come into an existing code base, I like to get a high-level overview of the condition of the code and the project itself. This is a list of some of the things I look for when I open a project for the first time or haven't opened a project in a long time. It's not a complete list, but it's a good place to start. First, does it build and pass tests? If you can't build the app, you're stuck with debugging this problem first. You can't do much with the app unless you can at least run it. And a part of this is running tests, particularly unit tests, and if they're available, end-to-end style tests or UI tests. The existence of tests is a form of documentation. And if the tests exist and pass, it means you have somewhat of a baseline of understanding the code. Second, CI/CD. In other words, continuous integration and continuous delivery. If you're lucky, you'll come into an existing project that already has these systems set up. This usually means an automated system that exists somewhere other than your local desktop that builds, runs the app, and ultimately distributes that app to an app store, for example, or somewhere users can get it. If the system exists, then it's important to understand how it works so you know how to safely change the code and get it through the system. If the system does not exist, then that's something you're really going to have to consider setting up and getting going. Xcode settings. Those are the settings for the app in general. This includes things like plist, xcconfig files, build schemes, build steps. All those things can affect your build. Just be aware what those settings are, whether or not they're up to date and need revising, and just to see where some things might be coming from. Dependencies and services typically take the form of frameworks that are brought in by a package manager like CocoaPods or Swift Package Manager, Carthage, or something else. While these dependencies may be desired, you want to make sure that they're not out of date, presenting any kind of security risk, whether or not they're poorly implemented in the app, and each dependency should be carefully evaluated to see if you really want them in your app. Secrets. Secrets are one of those things that most apps will have to deal with. So we want to make sure, though, that none of these types of information are actually in your repo. In other words, any kind of controlled information, API keys, personal identifying information, certificates, materials that you don't want to be available out there in the world, you just don't want in your repo. That means you'll probably have to come up with a way to get those secrets into your app, whether or not it's through the CI/CD system or some local system that you can inject while you're trying to build locally. But these are things that you need to be aware of. File formats and languages. Once you peruse your project setup, it can give you insights about the construction of the code. You'll see clues to the languages used in the app, like whether or not you have Objective-C files and Swift files, along with other important file formats like asset catalogs, zibs or nibs or storyboards, those sorts of things. You might come across some unfamiliar file types, especially if it's not something that you've worked on. So it's a good idea to just make sure you understand what is in the project. And once you identify the different languages, you might be surprised to realize that you need to also identify what dialects of languages you might have. Swift is on, I believe, version 6 at the time of this recording. That means there's possible holdovers from other versions of Swift in your code. And if you can, modernize it. Objective-C, on the other hand, there's two major versions of Objective-C. There's Objective-C 1 and Objective-C 2. Objective-C 1 has been used for a very long time. Objective-C 2, I guess, has also been used for a long time, but not quite as long. But there is a difference between the two. So check to see what files and formats are in your system. And associated with that, what formats are being used for the UI system? There are at least 3 different types of UI you can have in an app, including all 3 at the same time. What most developers will be familiar with is storyboards and zips. That is an interface builder approach to building your UI. Secondly, you could programmatically build your UI with AppKit for macOS or UIKit for iOS. So you can have those 2 methods, but there's now a third one where you can use SwiftUI to declaratively create your UI. So that's 3 different UI systems. You might have all 3 in a single app, and it might be a good idea to find out what's being used, what you can switch over to as few systems as possible. You can work with all 3, but it might be an easier approach to limit it to just 1 or 2. Memory management. In most cases today, memory management in the Mac and iOS is ARC, automatic reference counting. While this is a powerful way of managing memory, you can still make a ton of potential mistakes. So one of the things you want to assess is what kind of memory management is going on in the app and whether or not there's any memory management problems. Some of them will be easy to detect, some of them will take a little bit longer to find out. If the app is older, you might actually not have a code base that is set up with ARC. You might have garbage collection because there was a period where Xcode supported garbage collection, or you might have manual reference counting or manual retain release. And we'll talk about that in a little bit later. Asynchronous code. There are so many ways to do asynchronous code today. There is Grand Central Dispatch, there's combine, async await, closures or blocks, etc. That's not even getting into a lot of third-party systems like React. So we want to make sure that we have a good understanding of what asynchronous systems are being used in the app and whether or not we want to get rid of some older styles in favor from new styles. For example, if we have a lot of GCD, do we want to switch it over to async await? Color and font systems. If the app uses custom colors and fonts, are they handled systematically or are they handled piecemeal? In other words, are you declaring NS color or UI color all over the place? This sounds like kind of a strange one to be looking for, but it's kind of important because this is one of those areas where you can easily make a code base easier to understand by developing very systematic ways of using colors and fonts. And if you don't have that, you might want to consider doing it. And we'll talk about that a little later. Localization. Localization in this case does not mean that you fully translated the app. What I mean is that have you made the app localizable? In other words, are you using Apple's APIs to handle localization for all your user-facing strings? If you're not doing that, then what happens if you decide that you want a translated version of the app out? You'll have to go through the entirety of the app and fix all those localization problems before you can even deal with the translation. So you want to be able to have that as you're working, and when the call comes to translate it, all you have to do is export the right files, send them off the translator, bring it back in, boom, you're ready to go. I would consider this one of these table stake concepts. If you're really intent to get an app out there and have a large user base, this is table stakes. And finally, just like localization, accessibility is table stakes for any app that you want to have widely used. If it's just for you, I can understand why you might not want to deal with it, but if you want a large user base, accessibility is important. Now, let's face it, while Apple's made accessibility a priority and exposed great APIs to handle accessibility, it can still be hard to properly set your app up for accessibility. But if you can do it, something you really want to do. Again, it's table stakes. So when you get an app like this, one of the things you want to do is to audit the app for accessibility. Okay, so let's actually try to go through these things and evaluate the current state of the app. Now, for this video, I'm only going to do, does it build and CI/CD, and the rest of it we can look at in the next video. Before we get too far with this, I do want to point out we need to take note somewhere. So I'm going to pull out Apple's new app and create a kind of story map. So this is Apple's Freeform app, and I've already set up essentially a story map. I'm not using it as a true story map, but it's essentially a story map. So what I'm going to do is take notes on the work we have to do for the app, that as we discover it as we go through these items. So let's go back to the list. Does it build and pass tests? First of all, we have to download the repo, open it with Xcode, and just see if it builds and runs tests. There might be some special build instructions. We'll find out pretty quickly. If it doesn't build, we'd have to root around and see if there's any instructions. And most importantly, if it does build, do the tests that actually exist pass. So let's go through that process. Okay, now I have my terminal set up and I'm ready to go, but I need to know where the repo is. So I happen to have it opened up here in a separate web browser. So the code is up on GitHub. Now while we're here on GitHub, we can go ahead and take a look at a few things. First of all, you can see that I do have an MIT license set up for it. If we scroll down the right here, we can see that the code base itself is 80% Objective-C, 18% or so HTML, and maybe 1% something else. That's not really a surprise. Objective-C is going to be the language that existed in 2006 along with HTML, so there shouldn't be any Swift in here. That gives us a good starting point on the question about languages and file formats. The other thing you might notice here is there's no real directory system in this. Everything is just at the top level, which is kind of unusual in this modern age. And the reason why it's this way is that early versions of Xcode didn't actually help organize your files. It would organize files in Xcode itself, but it didn't actually physically move the files around into directory structures. That came a little later. And then if you didn't have it to begin with, you have to intentionally set it up to organize files in that way. So we learned a little bit about the code. So one of the things we need to do is make a note about organizations. So let's bring up Freeform, and I'll put this under Xcode. So we need to do something about file organization. Okay, so what do we need to do? We just need to pull the repo. So I'm going to get up here under the clone, and I'm just going to do an HTTPS for right now. Copy it, get rid of the web browser, go to terminal. So this is actually pointing to this folder in the top right. So I'm going to do git clone and then the URL. Boom, we got it. I have a bit of a fast computer and it's not a big project, so pulling it down is pretty quick. Now let's launch Xcode. So so let's open the repo in Xcode. So let's go into refactoring. Let's actually find out what the name of it is. PaleoRose. Okay, well now we're in the repo. We can see with my terminals being set up, we can actually see that I'm in the main branch. So let's open her up. So now we're in Xcode. Now I can see that I have some organization going on here in Xcode, but it's not the same thing as we saw in the file system on GitHub. So we're going to have to go through and fix all that. But let's build and run. Build succeeded. Test succeeded. I will say that I have cheated a little bit, that before I created the repo, I did get PaleoRose working before I created the repo. So if this was the real example, build would not have worked. We would have had to done some extra work. So one of the things that we can clearly see, though, we have some warnings. Take a look at these real quick. So we have some deprecated code, dragging, description with calendar, and then we have this C function static thing we need to fix. So let's make a note of it. Even though we can see it, let's bring up Freeform and add that. And what about tests? We ran tests. We had a successful set of tests. How many tests do we have? We have 4. So we have this class called XR statistics that has 4 tests. That's okay. It's not great, but it is a set of tests. You also have this test file that does nothing. So this one's been commented out, and the reason for that is very likely that the tests don't work, and we need to rebuild this particular set of tests. But that means most of the app has not been tested, and that's a problem. We need to start solving that. But the basic truth is, if the app has gotten this far and there's no unit tests, it's going to be really hard to write unit tests for it, because when you write code for unit tests, you write it in a different way than you would if you just simply write the code. So unit tests work, but they're in bad shape. Okay, so let's move on to CI/CD. What system does it use? Does that system support all our needs, including Swift Package Manager? Swift Package Manager is relatively new, and some systems may not quite work right. Does the system have clear ownership? In other words, is the system owned by whoever owns the code? That's kind of an important thing, because if it's a different set of ownership, there may be long-term problems. Does the system support different environments? If you have networking going on in your app, you might have to have a dev environment where you can talk to a network service that isn't production. And then you might have a production version. So does that system support those different environments? What is the build strategy? Are you going to build every time you make a commit? Every time you want to make a release? Does the system have a CD? In other words, is it automatically distributing the app? And finally, are tests run on the system? If they're not being run, you also have a problem. You want your CI/CD system to run tests. And really, we can just go into Freeform from here. Why am I going straight to Freeform? Well, I know that this app has absolutely no CI/CD, so we need to build it. Chances are I'll probably do it through GitHub, because you have a limited amount of free build time there. But we also have to make decisions about when it will build and when it will distribute, if it does distribute. So we've covered a lot of information so far, and we have a few notes down, which is all pretty exciting. So next time, we're going to go through all the rest of the items on our list and see if we can fill this diagram out a little bit of the things we need to do. So go ahead and hit like and subscribe if you're interested in following this project, and feel free to leave comments. Let me know what you think and provide your own ideas on how we can work with this app. So remember, you can pull this app yourself and try the same things. Good luck. Hope to see you next time.